It can be said that the EWI building is the landmark of the TU Delft. To profile itself as progressive in the field of sustainability, why don't we use this building as a showcase example? Natural forces like geothermal energy, wind and solar radiation should replace finite resources to reach out for zero energy use buildings. EWI has a height of 90 meters. The high-rise building's potential of self-generating energy has been left unexploited. Therefore, our research question is, how could the height of the EWI building influence its sustainable performance? The EWI as a high slab building is oriented with its plain facade towards the southwest. This facade catches a great amount of solar radiation. The total surface of this facade is more than 7,000 square meters. With this orientation and location, that means the potential energy absorption of this facade could cover 1/3 of its own total energy consumption. The bigger the facade surface, the more absorption of solar radiation. The big house in Hamburg is one of the first examples that uses algae bioreactor panels. The nutrients-containing water within the panel heat up by solar thermal effects. The bioheat is stored and used to warm the building. At the same time, daylight and CO2 is converted into biomass through photosynthesis. The biomass is partly converted into electricity and used for the electric machinery. As a side product, the algae bioreactor panels produce oxygen and minimize CO2 levels. This system applied to the EWI facade could approximately serve 300 households. Manitoba uses the sun in a different way. It establishes a natural ventilation by making use of a solar chimney. The ventilation inflow of air is situated opposite of the solar chimney. This is where a waterfall feature humidifies air as it enters the building. The solar chimney draws used air up and exhausts it out of the building. Optionally, the heat is used to warm the building. During winter, the entering air is preheated in the facade boxes. Heat exchangers recapture heat and return it into the boxes. The opening on top of the chimney is directed opposite to the average wind direction to benefit from the highest underpressure. Where Manitoba is using geothermal heat, EWI is using mainly gas. Compared to EWI, Manitoba is much more sustainable. EWI consumes the same amount as 5,000 households. This is a small village and 3 times the amount of Manitoba's energy consumption. So in comparison, EWI is not doing well regarding energy use as well as the CO2 emissions, which are 10 times higher than Manitoba. This is mainly due to the fact EWI uses gas and Manitoba's capacity of reusing heat gain. The wind in Delft is mainly coming from the southwest. Before finding a way around EWI, overpressure is being built up, causing high wind speeds around the building. The higher a building is, the higher the wind speeds around it. This causes a lot of nuisance. However, why would you decrease wind speeds when you could profit from them? The World Trade Center in Bahrain uses wind velocities as an opportunity. It takes advantage of its height by placing wind turbines in the middle of the 2 towers. The 2 towers are especially designed to increase the wind velocities, making the turbines rotate faster and produce more energy. Within a year, the turbines produce 11 to 15% of the building's total energy consumption. The climate circumstances of EWI compared to the World Trade Center are very similar. The wind hits both buildings with the same angle and the same wind speed. This means EWI offers opportunities for energy generating devices based on wind. This could be done like this, or this. Now, how could the height influence its sustainable performance in a negative way? First, there is a relation between the amount of resources needed and the height. The higher the building, the higher the amount of construction material per square meter. The same relation appears to exist between the height and the amount of energy costs per square meter. Even though Manitoba has around the same amount of square meters, there are working twice as many people. In EWI's current office organization, every person uses 20 square meters, while according to Neufert, 12 square meters would be enough. This could be achieved by replacing the traditional office rooms with open plan offices. Applying this idea to EWI would reduce the height with 7 floors. Despite the louvers between the double facade, the current system of EWI causes heat gain in the southwest part. The incoming air of the ventilation is preheated or cooled in facade boxes. Then the air ventilates the room to eventually exhaust through ventilation grids due to mechanically driven fans. Unfortunately, employees need storage space and fill up the room with closets. Covering these grids and therefore blocking the ventilation, causing awful headaches. Replacing a traditional floor system with a prefab construction, including an integrated climate system, can decrease energy costs during the construction phase with factor 5. So, we have seen how the height of the building can have a positive and negative impact on the sustainable performance. The question remains, what would be better?